Hello, and welcome to Serverless 101. My name is Eric Johnson, and I'm a Principal Developer Advocate for Serverless at AWS. Serverless 101 is a video series to help you get acquainted with the AWS services that are serverless. In this video, I cover AWS Lambda. We'll talk about what it does and when you should use it. Let's get started. AWS Lambda is a secure, on-demand, event-driven compute service that scales as needed and billed only for what is used. Okay, I crammed a lot into that sentence. Let me unpack that a bit. The words I used are secure, on-demand, event-driven, compute service, scales, and billed only for what is used. First, I'll define compute service. To do this, let's look at a legacy way of building web applications. Before serverless, when a new web application was needed, it required a server. On that server, somebody, often the developer, would need to install, at a minimum, a firewall, web server, and the code for the application. The code itself needed to handle routing, authentication, authorization, caching, throttling, and, at some point, the actual business logic for the application being built. At AWS Serverless, we believe that the critical part is the business logic. The rest is what we call undifferentiated heavy lifting. So, with AWS Lambda, we built a compute service that abstracts all that other stuff away and allows developers to concentrate on the business logic that makes their application special. This business logic can be run in any of the supported runtimes: Node, Python, Java, .NET, Ruby, Go, or you can use our custom runtime to support any language you choose. Now, I know what you're thinking. What about all that other stuff? Well, things like infrastructure security, server management, load balancing, and more are handled by AWS. Yes, there are servers in serverless, but you don't need to manage them. Additionally, other application requirements that you may need are handled by services that are discussed in other installments of this series. For example, see Amazon API Gateway for routing, throttling, and authorization. You'll notice one of our words popped up there: security. AWS manages security for you by maintaining the data centers, patching and securing the servers and operating systems, providing identity and access management tools for your infrastructure, and helping you encrypt your data in transit and at rest. AWS helps you with security in many other ways too, but you get the idea. So, if AWS is managing everything outside of business logic, how does that business logic get invoked? Let's look at another of our terms, event-driven, to explain this. Returning to our legacy application, before serverless, in order to respond to API calls, CLI commands, or other types of requests, a server had to be listening on a designated port 24 hours a day, 7 days a week, 365 days a year. With Lambda, AWS changed this model. A Lambda function never sits idle listening for a request. Instead, it is invoked by the Lambda service when an event happens. In this event-driven model, an event can be any number of things. For example, an API call, a file saved to Amazon S3, a click of an IoT button, an update to a database table, and so much more. If some of these examples do not make sense, don't worry. I cover these in other installments of the Serverless 101 video series. The main point is, any of these can be an event that causes the Lambda function to be invoked. When the code within the Lambda function is complete, the execution environment of the function is then frozen and ready for the next event to occur. This brings us to our next term, on demand. As previously stated, there's never an idle Lambda function waiting for a request. Instead, a Lambda function is only invoked when needed. Therefore, the amount of functions in use is directly correlated to the demand required. To better explain this, let's bring in another of our terms, scale, and return to the legacy application for a moment. Before serverless, if you needed a web application that was highly available and could handle heavy loads, it required a large infrastructure that you had to manage. The infrastructure generally included many servers in multiple zones with load balancers and failover plans. Again, all managed by you. AWS Lambda changes this model as well. Instead of managing multiple servers across multiple locations, you only manage one instance of your code in a Lambda function, and AWS scales to handle the load as needed. For example, I have a Lambda function that removes sensitive data from provided input. I will call this the scrubber. The scrubber Lambda function is configured to invoke anytime a new document is saved to my Amazon S3 bucket. When the scrubber Lambda function is invoked, the event data contains a bucket name and key name, aka the file name. The Lambda function then reads that file, uses Amazon Textract to scrub the data, and saves the output to a second S3 bucket. So, what happens when a whole bunch of files get dropped into the bucket at the same time? The Lambda service will scale as needed to handle the requests. When more requests come in, the Lambda service checks to see if there is a frozen execution environment ready for use. If there is, it unfreezes that execution environment and invokes the Lambda function with the next event. If not, the Lambda service spins up a new execution environment with the same Lambda function code and invokes the function with the next event. An invocation in a new execution environment is called a cold start, while an invocation in an existing execution environment is a warm start. I now add a second Lambda function that creates a PDF file from each of the files dropped into the original bucket and saves them to a third bucket for historical value. I call this the archiver. As files are dropped into the first bucket and the scrubber Lambda function goes to work, the archiver also goes to work independent of the scrubber function. The Lambda service continues to create new execution environments for both Lambda functions until the work is done. Notice, by using this pattern, processing many files is done in parallel rather than one at a time linearly. This allows you to get more done in less time by utilizing nearly limitless compute power. After that, if no more files are dropped into the bucket, then the Lambda service starts removing execution environments as they time out, eventually scaling to zero. With that in mind, we should probably talk about costs. Remember, I stated that you are only billed for what you use. Billing for a Lambda function starts when the execution environment is created or unfrozen and ready to run your code. Billing stops when the execution environment is placed into a frozen state. Many times, this is a matter of milliseconds, depending on what you are doing in your code. The nice thing is, Lambda function billing rounds to the nearest millisecond. AWS Lambda billing varies by the region and the architecture used. For example, an ARM-based Lambda function in the US East 1 region is billed at 0.000133334 for every gigabyte second and 20 cents per 1 million requests. However, this is after the free tier of 1 million invocations per month and 400,000 gigabyte seconds of compute time per month. That's every month, forever. To put this in easier terms, let's say I have 1.5 million requests and each takes about 1 second. Because I have 2 Lambda functions being invoked, this is actually 3 million requests. This would cost roughly $1.87 in gigabyte seconds and 40 cents in requests, totaling roughly $2.27 per month. This is using ARM and after the free tier applies. There you have it. We have broken down the definition of AWS Lambda, and hopefully you have a better idea of what the Lambda service does. Let's take a look at some use cases that are a great fit for AWS Lambda. Data processing, interactive workloads, chatbots, cron jobs, Alexa. While this is not an exhaustive list, it gives you an idea of the power of Lambda functions. This has been a high-level overview of AWS Lambda. I encourage you to dig into the individual features of Lambda to make it work well for you. For more information about AWS Lambda and other videos in the Serverless 101 series, follow this QR code. Again, my name is Eric Johnson, and you can connect with me at EDJGeek on Twitter. Thank you.